So I want you to imagine something for a second. What if, what if 95% of the universe is just, well, a colossal math error?
I mean, it sounds wild when you say it out loud like that.
Right. Like, what if the Big Bang never actually happened and the cosmos we live in is, I don't know, less like a mathematical equation and much more like a gigantic churning piece of industrial plumbing?
Yeah, industrial plumbing is definitely not how they teach it in grad school.
Definitely not. Welcome to today's deep dive, everyone. If you're listening to this right now, you might be thinking, that sounds like pure science fiction. But recently, astronomers looking through the James Webb Space Telescope, the JWST, have found things out there in the dark that are absolutely breaking the current laws of physics.
They really are. It's a fascinating moment to be observing astrophysics right now because when the incoming data just outright refuses to match your accepted model, you find yourself in a full-blown cosmological crisis.
A crisis, yeah. And that's exactly what we're looking at today. Because the standard model of physics, I mean, obviously it's given us incredible insights, but
It relies so heavily on mathematical abstractions. It actually requires the existence of phantom matter, things like dark matter and dark energy, just to balance its own equation.
just to make the math work.
Exactly. And when a crisis like this hits, the scientific method demands that we evaluate new frameworks. We have to be willing to look at the data through an entirely different, maybe even uncomfortable lens.
And the lens we are using for this deep dive is definitely going to make some people uncomfortable because it requires throwing out a lot of assumptions. So we're pulling from a grounding document today titled Technical Supplement, Resolving JWST Anomalies Under the Engineering of the Universe Framework.
Authored by engineer Daniel Correa.
Right, exactly, outlining the Correa theory. Now, our mission today isn't to boldly declare that traditional physics is dead and buried, right?
Yeah.
But we want to see what happens when we shift our perspective. Like, what happens if we stop treating the universe as a geometry problem, missing some invisible variables, and start treating it as what was the term? A dynamic flow reactor reservoir.
Yes, dynamic flow reactor reservoir. And that phrase is, well, it's the absolute key to this entire framework. We're talking about looking at the universe through the hard, practical laws of fluid mechanics, mass balance, and thermodynamics.
Okay, let's unpack this, because when I was reading through the source material, the best way I could visualize it was imagine if astrophysicists have spent the last 100 years trying to fix a software bug in the universe,
Right.
like writing increasingly complex code to make the simulation run. But this paper suggests the problem is actually in the plumbing, like the hardware itself.
I really like that analogy because if you view the universe as a physical thermodynamic process, a massive fluid system, rather than a purely geometric abstraction of empty space, then the massive anomalies currently baffling the James Webb team might not actually be anomalies at all.
They're just doing what they're supposed to do.
Exactly. They might just be the natural, predictable behavior of a fluid system doing what fluid systems do.
Wow. Okay, so if we're going to talk about a crisis, I feel like we have to start with the specific anomaly that triggered it, right?
We do, yeah. The little red dots.
Yes. For the JWST, the giant wrench in the gears was the discovery of what the astronomical community calls the little red dots, or LRDs.
Yeah.
Now, I know you listeners who follow astronomy are probably familiar with this, but the JWST pointed its sensors at the absolute farthest, oldest observable reaches of the universe.
Way back to the very beginning, supposedly.
Right. And according to the traditional Big Bang model, looking that incredibly far back in time means we should only be seeing the earliest, most embryonic structures, tiny, disorganized infant galaxies just starting to pull themselves together out of the gas.
But that is emphatically not what the telescope found.
It's not even close.
No. Instead of infant structures, it found these little red dots, which, when they looked closer, turned out to be massive, mature, heavily populated galaxies.
Which shouldn't exist.
Right. They were sitting right there in an era where the standard Big Bang model explicitly stated they had absolutely no business existing. They were physically way too big and structurally way too old for the universe to have just been born, a few 100 million years prior.
Okay, hold on. Let me stop you right there, because this is where the Correa theory takes a massive swing. You're telling me that based on these massive galaxies, this framework suggests the Big Bang, like the foundation of all modern astrophysics, the thing we've all been taught is undeniable fact, is just a misinterpretation.
That's what the framework proposes, yes.
That is a gigantic claim. I mean, how does Korea justify just throwing out decades of established cosmology?
Oh, he justifies it by fundamentally changing the state of the system. In his framework, the universe operates on what he calls a multiversal recirculation cycle.
A recirculation cycle,
Yeah.
okay.
And in a system like that, there is no absolute time zero. There is no singular starting point where everything suddenly springs from a vacuum in a massive explosion.
So the universe wasn't born from nothing. It's always circulating.
Precisely. In the standard model, there's this energetic injection, what we call the Big Bang, that we mathematically interpret as a singular beginning. But what's fascinating here is how this theory recontextualizes everything.
How so?
Well, if space is a dynamic flow reactor, it's an ongoing process.
Mm.
The Correa theory suggests these massive mature galaxies already had mass and they already had structure long prior to that localized energetic event we call the Big Bang. Yeah. They aren't impossibly old infants that somehow grew to adulthood in an instant. They were just existing within a steady state or cyclic flow regime. Basically, they were already there.
Okay, I hear you, but if we're going to throw out the Big Bang, we really have to address the giant elephant in the room, redshift.
Ah, yes.
Because the whole reason we believe in the Big Bang and an expanding universe is because of redshift, right? When we look at galaxies, the light they emit is stretched out. It shifts its wavelength toward the red end of the spectrum.
Right, which the standard model interprets as velocity.
Exactly. The standard model says this happens because the galaxies are physically racing away from us, like dots on a balloon being inflated. High redshift means it's running away really fast. So if the universe isn't expanding, then what on earth is causing that light to stretch?
Well, in this engineering framework, redshift is fundamentally not a measurement of expansive recession. The universe is not a balloon expanding away from itself. Instead, redshift is interpreted through fluid mechanics as a drag effect.
A drag effect.
Yes. Specifically, it's called photonic head loss, and it's caused by light traveling through a universal fluid medium.
Wait, so if we see light stretching, you're saying it's not because the galaxy is running away from us like a speeding car. It's because the light is getting tired or encountering friction, like trying to sprint through a swimming pool instead of across a track.
That is a highly accurate way to look at it, actually. Yes, that is exactly the paradigm shift we're talking about here.
That's wild. So space isn't an empty vacuum.
No, the standard model treats space largely as a geometrical void. But if the universe is filled with a fluid medium, then nothing, not even a photon of light, travels through it without encountering physical resistance.
So instead of a speeding car driving away from us, it's like firing a bullet into that swimming pool. The water physically resists the bullet, slows it down, drains its energy.
Exactly. When light travels across these vast, unimaginable cosmic distances, we're talking billions of light years, it has to push through that universal fluid.
And it gets tired.
Right. In engineering terms, when fluid or energy moves through a pipe and loses pressure due to friction, we call that head loss. The energy of the photon dissipates slightly over those massive distances due to that drag effect.
Oh, I see.
So the photon loses energy, its frequency drops, and we observe that loss of energy as the light shifting to the red end of the spectrum.
That completely flips the script. I mean, if redshift is just friction, if
Right.
it's just the drag effect of light swimming through the universal fluid over billions of years, then those distant galaxies aren't necessarily racing away from us at all.
They could just be sitting there in the flow.
Right. The universe isn't expanding. But okay, that raises an incredibly obvious question. If the universe isn't expanding, then why do astronomers keep arguing about the speed of that expansion? Which brings us right to the Hubble tension.
Ah, yes. The Hubble tension. This is the anomaly that has been keeping cosmologists awake at night for the better part of a decade.
Right, because, if the universe is just a balloon blowing up uniformly, the math for the expansion should be identical everywhere you look. The Hubble constant should be, well, constant.
But it isn't.
No. When astronomers measure the expansion locally, they get one number. When they measure it further out, they get a completely different, mathematically conflicting number.
Which breaks the standard model's rules entirely. The geometry just doesn't work. But how does the Correa theory handle it? It handles it by applying fluid dynamics.
Okay, lay it on me.
According to Correa's interpretation, what astronomy is incorrectly calling expansion is actually mechanical suction work.
Suction.
Yes, and this suction work is being performed by what he terms return black holes.
Okay, stop. Mechanical suction work performed by a black hole. You're going to have to explain the mechanics of that, because when I think of a black hole, I just think of a super dense gravity well. How does a black hole act as a suction pump in a fluid system differently than traditional gravity?
Well, it requires looking at the macro structure of the system. Remember, we established we are treating the universe as a dynamic reactor reservoir.
Right, the plumbing.
Exactly. In any active fluid system, you have to have input flows and output flows to maintain the cycle. Return black holes function essentially as the macroscopic drains or the exhaust valves of this reservoir.
Oh, so they aren't just heavy objects sitting there.
No, they aren't just sitting there passively having heavy gravity. They are actively performing mechanical work, drawing the universal fluid medium into themselves and funneling it out of the immediate system.
Here's where it gets really interesting, because tying that back to the plumbing metaphor, it's like looking at water flowing down a river.
Yes, exactly.
The water doesn't move at one uniform speed. It moves at different speeds depending on the rocks, the depth, the currents, and where the drains are. The flow rate changes based on the environment, rather than the riverbed itself physically stretching out underneath the water.
If we connect this to the bigger picture, recognizing these pressure gradients fundamentally shifts astronomy from abstract geometry into practical fluid dynamics. Because the universal fluid is not perfectly smooth or perfectly distributed.
It's clumpy.
Right, it is non-homogeneous. It has varying densities in different sectors. And because the fluid is non-homogeneous, the drag coefficient changes based on how dense a particular sector of the universe happens to be.
Meaning light traveling through a denser sector of the universe experiences more friction, and light traveling through a less dense sector experiences less friction.
Precisely. And when you factor in the mechanical suction work of these return black holes creating localized pressure gradients across the reservoir, well, the Hubble tension is completely resolved. The math balances perfectly.
Because the Hubble tension isn't a crisis of the universe expanding at impossible conflicting speeds. It's simply proof that the universal fluid has different densities.
Yes.
Astronomers are just measuring different flow rates and different drag coefficients in different parts of the cosmic river and freaking out because they thought they were measuring a balloon expanding.
The anomaly disappears entirely when you stop treating space as a geometrical void and start treating it as an active physical fluid environment. It's essentially engineering common sense applied to astrophysics.
I love how satisfying that is. Just clicks. But if I'm playing devil's advocate here, there is one massive piece of evidence for the Big Bang that we haven't touched yet. The baby picture.
Ah, the cosmic microwave background, the CMB.
Right, the famous map of the early universe. For anyone listening, the CMB is that speckled oval map of blue and green and yellow that NASA loves to publish. We've always been taught that the CMB is the ultimate, undeniable proof of the Big Bang.
The fading echo of the initial explosion.
Yeah, exactly. The residual flash of heat from that explosion cooled down over 13.8 billion years. If the universe is actually this massive churning fluid engine with suction and drag, what exactly is the CMB in the Correa framework?
Well, to understand that, we first have to look at the anomaly within the CMB itself. Because the standard model actually really struggles with it.
It does.
Oh, yes. When we look at the cosmic microwave background, it is not perfectly uniform. There are tiny, incredibly subtle temperature variations across the map. These are called anisotropies.
And the standard model has a really hard time explaining why those temperature variations exist, right? Because if everything came from one impossibly dense uniform singularity explosion, the residual heat should be perfectly smooth.
Exactly. It should be uniform. To make the math work for those anisotropies in the standard model, physicists had to invent a concept called cosmic inflation.
Oh, I've heard of that.
Yeah, it's the idea that the universe expanded faster than the speed of light for a tiny fraction of a second just after the Big Bang. It's an abstract, unprovable mathematical patch required just to explain why the CMB looks speckled instead of smooth.
Let me guess. The Correa theory doesn't need to invent a faster-than-light expansion patch to explain the temperature variations.
It does not. Because in Correa's interpretation, the CMB is not the fading echo of an ancient explosion at all. It is simply the equilibrium thermal radiation of the total mass contained within the universal reservoir.
Equilibrium thermal radiation. Okay, put that in plain English for us.
Yeah.
Are we talking about the baseline heat of the system itself?
Yes. Think of the universe as that dynamic flow reactor. It is a massive, heavy machine full of fluid in constant dynamic motion.
Okay.
Those anisotropies, those tiny temperature variations we see on the map, are exactly what you would expect to find in any fluid in motion. If you have pressure gradients, suction, and friction, you are going to have variations in heat.
Makes sense.
The CMB is just the natural temperature and density profile inherent to any active system.
So what does this all mean? If I'm the listener looking at one of those famous colorful CMB maps, I shouldn't be thinking I'm looking at a baby picture of the universe from billions of years ago. You're saying I'm looking at a thermal camera pointed at a giant engine that is running right now.
That is precisely what the framework suggests. You are looking at the stable operating temperature derived from the internal energy balance of a vast ongoing process.
It's happening right now.
Yes. Looking at the universe as an active machine rather than a historical artifact solves the inconsistencies without needing magical cosmic inflation. The universe isn't slowly cooling down from an ancient explosion. It is actively maintaining its operational equilibrium.
It's just humming along, doing its mechanical work. Which brings us to the grand, overarching claim of the Correa theory. And honestly, this is the part that genuinely made me laugh out loud when I realized the implications.
The dark matter connection.
Yes,
Yeah.
we hear all the time in science media about how normal matter, like everything we can see, touch, interact with, all the stars and planets, makes up only about 5% of the universe. The other 95% is dark.
Right. Dark matter holding galaxies together and dark energy pushing them apart.
The phantom matter required by the Standard Model's equations. But the Correa theory states that this entire 95% of the dark universe is simply a massive mass balance error.
It is a profound and highly controversial assertion. The theory argues that all those mysterious gravitational effects we attribute to invisible dark matter and all that expansive force we attribute to dark energy are actually just the natural results of the drag effect generated by the system's fluid dynamics.
Because we ignored the drag. We ignored the physical friction and the pressure gradients of the system, and so when our math didn't add up, we just invented invisible matter to fill in the 95% gap.
Pretty much.
It's like checking your bank account, seeing you are completely broke, and just inventing the concept of dark money to balance your budget so you don't have to admit your math was wrong.
It highlights a very real danger in theoretical physics, which is mistaking the map for the territory. When you rely solely on geometry and mathematical abstraction, and you divorce your model from the physical mechanics of mass, friction, and heat, you end up having to invent ghosts to make reality fit your equations.
It is wild to think about. It really proves how profoundly shifting your foundational assumptions can turn anomalies into perfect evidence. Move from empty space to real physical fluid processes, and all these massive James Webb problems just vanish.
They cease to be problems at all. The massive little red dots, the conflicting math of the Hubble tension, the temperature variations in the CMB, they stop being crises that threaten to break physics. Instead, they become perfect, harmonious evidence of a fluid, cyclical cosmos.
It's a completely different universe, or rather, it's the exact same universe, but we're finally looking at the machinery clearly instead of, being confused by the shadows it casts.
Which brings us to the ultimate implication of all this. This raises an important question, one that I think you, listening to this, should really ponder as you go about your day.
Oh, I'm ready.
If the Correa theory is right, and our universe is essentially a dynamic reactor reservoir governed by fluid mechanics, and it exists within a larger multiversal recirculation cycle defined by dynamic input and output flows.
Wait, if we have return black holes acting as drains, then there has to be a source.
Exactly. Where exactly are those inputs flowing from? What external system is feeding the reactor of our universe? And perhaps more importantly, what larger, incomprehensible system is the exhaust of our universe flowing into?
That is the ultimate thought experiment. So the next time you look up at the night sky or you see one of those breathtaking James Webb images on your feed, don't just think about empty space and the ancient ghosts of a Big Bang. Imagine you are staring right into the heart of a massive churning engine. You aren't looking at a broken mathematical equation. You are looking at the physical plumbing of eternity, flowing in from somewhere unknown and flowing out into something else entirely.